Right, okay, now we're going to move on to effectively numerical integration. So we're going to try and integrate, i.e. find the area under a curve by using numerical methods rather than by doing direct integration. So if we've got a curve of some description and we're trying to find out the area under the curve between a couple of limits, then what we do is we split the domain up into a number of points. So we have x1, x2, etc., all the way up to xn, and so this is our x-axis, this is our whatever our function is. So this point here will be the function value of x0, this will be the function value of x1, this will be the function value of x2, etc. And as you can see, it gets kind of messy once you start going downhill again. In our formula below, we have an h, which is the distance between any two consecutive points that we're going to be using. Okay, so this formula here will give us an approximation for the integration. So the approximation for the integral of the function between x0 and xn, so that's the total area under here, is approximately equal to h over 2. So h is the integral as the interval distance divided by 2 with this lot here. So it's the first function value and the last function value once each, and all the other ones get counted in twice. And effectively what this is doing, it's just making a bunch of trapezia. So it's just splitting each of these into a trapezium, and because the first one and the last one are only in one trapezium each, they only get counted once, and the ones in the middle each occur in two trapeziums. So this one here is in this trapezium, and it's also in this trapezium, so it gets counted in twice. And this is what's called the trapezium rule, and it will give us an approximation for the curve. And the closer the curve is to straight lines, the better the approximation will be. But we'll talk about the accuracy of the approximation when we come down to error bound down the bottom here.